It is possible, almost 30 years at a company like Microsoft, to have two lives, two careers. I'm going to do something that I don't normally do. I haven't done in a long time. For the next 50 minutes, I'm going to give you a taste of my career at Microsoft for the first 20, which is a lot different than now. I didn't do keynotes and Dungeons and Dragons and talk about what's new in SQL Server back in the days. I did a lot of what you're going to see in the next 50 minutes. And what I want to do is show you a couple things. I want to pay homage to a couple of people that aren't here. Robert Dorr and Keith Elmore. So those guys both work in engineering now, but they used to both work with me in CSS and support. And what I'm going to show you is some of the techniques of problems that we faced. Nobody used to call us back in the day and say, I love SQL Server, everything's running great. In fact, what they did at some point is call somebody first to talk about a problem, and eventually those people talked to somebody else, and eventually came to the three of us and said, we have no idea what to do. Can you help? And it's all about debugging the SQL Server product. Couple logistics. The deck is right there at AKMS Bobward MS. The demos I'm going to show you are at Bob SQL Demos. Here's the problem. Some of the demos I'm going to show you, you can't do. Because I'm going to use some private stuff that we do inside Microsoft to go simulate some problems that we debug in SQL Server. But you might kind of have fun seeing what it looks like, and some things you actually can try for yourself. How about questions? First of all, I'm going to be impressed if you have some questions. And if you do, maybe I should hire you, right? But let's do it this way. If you're online, thank you for being online. Have Mark here in front of me to help me. I'll take some fixed points in the talk to take questions. So if you've got some, hold them up until I get to those fixed points. If you're here in the room, we have some sort of fun boombox thing for you to do that with, but don't break it, please. I guess it's pretty valuable. So let's just start. Let's talk about this. I'm going to do some stuff today. Do not go in production and do, okay? Unless under the guidance of Microsoft, like under the guidance of support team or me myself from engineering team. I think you're going to enjoy this. I did this talk at the past summit, had a lot of people walk up to me and say, I had no idea what the heck you were talking about, but I loved it. I'm not sure how to take that, but anyways, I thought it'd be fun to put together and show you a piece of what it was like in the past. So here's what we're going to do. Talk a few fundamentals. We're going to show you how we debug something called an access violation. We're going to show you how we debug something called a hang, like a non-yielding problem. We're going to talk about a few stranger things like Spinlock debugging. And then some, at the very end, hope we'll have time. If I don't, it's okay. A very unexplainable CPU case that Robert Dorr ran into, and he used a tool that's pretty interesting to go solve a problem that we commonly use when we have no else what to do to solve a problem in SQL. So a couple things about some basics. We're going to use the Windows Debugger quite a bit today. I think, a lot of times I go present at Microsoft and people are like, hey, where's that debugger thing? I'm like, hey, I don't do that anymore. So I'm flipping back to a day, an age, when that's all I did almost all the time to solve some complex problems. We'll use symbols as a part of a way to go debug certain problems. You need to know a few things that are available to you, though. This really incredible tool by Arvin called SQL Call Stack Resolver. We're not going to use that today. I'm going to use that in the Hidden Gems session on Saturday. But that is a way for you to do some information that might come from X event, called a stack dump, to go analyze some problems in SQL that even you can go take a look at and decide what kind of issue it is. I'm going to be talking a little bit of, I'm going to show you some assembly instructions, yep, some registers. I'm going to look at some threads, workers, tasks, requests. I'll talk about some X events that can help you in certain situations. The dbcc stack dump command is something that actually could be used to actually look at what's called a stack dump. There's a program called SQL Dumper that we use internally to go generate something called a stack dump that we'll look at. And at the very end, that one tool we may or may not get to is called XPerf to solve this unexplainable CP problem. So let's dive right in. This is one of those no fluff sessions. We're just going to go right into the tech. Let's talk about an access violation. It was a very common crash scenario. So this is kind of the address space of a process like SQL Server. And as it turns out, in like the Windows operating system, what we do is we mark pages in the virtual address space as called no access by default, which means if a program ran an instruction to go touch an address at those spaces, you would result in an access violation. And in fact, we mark the first sections of this virtual address space, 64K, to catch something called null pointers. When somebody has a pointer in the code, you try to read to it or write to it, you're going to automatically catch an access violation. Now what SQL Server does, which you see it do in its memory management, is allocate memory that's mapped into the address space, and the status of pages, these are like Windows pages, inside the process space are marked read-write. So it's legitimately okay for us to go read from those and write from those. But if there's some bug in our code where some pointer that normally points to some buffer pool page gets damaged and starts pointing off into one of these no-access regions, it will result in an exception, and it literally happens at the actual processor level, for an access violation, because you cannot touch a page that's marked no access. So, when anybody has a pointer in their code that tries to go read or write from any of these regions that are no access, there's an access violation. The most common one is null pointers, like somebody made a mistake in the code, I didn't assign a reference to an address, I will actually get an AV because of that. Now, one of the things we did was really interesting. We have a trace flag on our system that's kind of like not completely documented, to try to catch what we call scribblers, like pieces of code that may try to hack and write on top of our buffers. So we turn on this code 815 called buffer latch enforcement, and if somebody else besides SQL Server tried to go write into our pages, because we mark it read-only and they tried to write into it, we'll generate an access violation. Because it turns out, if a page is read-only in the process space and you write to it, that's also an access violation. That's a pretty nifty technique that we added back several releases ago. The CSS team worked the engineering team to catch what we call something called a scribbler, which could be a bug or could be somebody trying to inject an attack to write something into SQL Server, which could lead to like database corruption problems. So there are certain things we saw over time that was very interesting at Microsoft. And it wasn't just bugs in the code. Things like bit flips. What do I mean by bit flip? Like literally registers in SQL Server where one bit was off. Or like a stale pointer, like a pointer that references a page like on disk that would all of a sudden we would read back would be wrong. Or can you believe it that you would call Microsoft back in the day in tech support, you would call me, and I would look at this problem and I would see these access violations happen all over our source code, like hundreds of them. Every different instruction. I would see access violations happen in the most common code in SQL Server, and I would tell a customer, it looks like bad hardware. They're like, no, it's SQL Server. You're the one producing this access violation problem. It must be your code. I'm like, okay, we'll keep debugging it. Get a call about, a week later. Well, it turns out we replaced some of the, motherboard and a couple of chips and everything's gone away. So it turns out when you see yourself these access violations in SQL Server and they look like they're just everywhere, because you can tell, I'll show you an example of one of where we catch in the code in SQL Server where it happens, and it just randomly happens everywhere, there actually could be a problem with your hardware. Another situation is a database corruption problem. So I would have customers, would get access violations all over SQL Server. We would trap it in the error log with all these things. And I would say, let's run a check DB. And they're like, why? I said, well, as it turns out, if the database page is corrupted, inside the pages, there's values that we use as pointers in our code. And if we go use a value as a pointer, we might run into one of these problems. So it's not just bugs that happen in SQL Server. It can be, and often it is, but it's often interesting problems like that you ran into. Okay, let's go look at one. Let's quit looking at slides. Let's go look at some code, right? So I'm going to show you first in Visual Studio a program I wrote that generates an access violation. Now look right here. X is a pointer, like an address, like I showed about, and notice I'm assigning it 0. So what I'm going to do is I'm going to have X be 0, and what am I going to do with X? I am going to try to write into it. So in this instruction, in that previous slide, I'm going to write to 0. What's going to happen? It's going to be in that null address range, and it's going to trigger an access violation. So if you wrote your own code, and this happened, this is what it might look like. And you're like, what the heck is this? What is this exit code right here? I don't understand this. Well, if you convert that to hex, which you all know how to do, right? You do this all the time. It looks something like this. It's this hex value, C with a bunch of zeros and a 5. Well, you're like, well, I don't know what that is. Turns out the Windows team does. They have a series of exception codes. So I'll go over and show you what that looks like. Let's go here. And I will search on that, and I will find it right here. C005, which is an access violation. So, as it turns out, a normal program could actually crash because of an access violation. Now, it turns out what you can do is you can do something like this in your code. You can comment this out. You can do what's called an except block, a try except block. So if an access violation occurred or any exception, you can handle it. Let's go do this again. Let's go actually build this thing. Build solution. And let's go run it. Ah, look at that. So notice in my code here, I had what's called SEH block. That was my print right here. So I caught the access violation. Why am I showing you this? That's what SQL Server does. For the most part, for most access violations, you don't know what's happening. Because we in our code decided many years ago to catch these things, terminate the session, roll back the transaction, and let the server still run to keep you available. There have been some cases over the years where that was a bad decision. Because we're trying to keep the server alive, but you've got some bad hardware problem. We can just keep generating access violation after access violation, and your server becomes actually unusable. But for the most part, that served us really, really well. So let's do something even more fun. You're like, Bob, can you generate an access violation? I can. So I'll show you something pretty cool. A technique that we use inside Microsoft to test exceptions. So let's try that. This is going to be interesting. So many command windows, I forget where I am. Okay, we have something called a debug server at Microsoft. It's a debug build of SQL Server we use privately. And guess what? We can run it from the command line without installing SQL Server. It's like a package. We call it an Xcopy build. So I'm going to run that for a very important reason. Let's kick it off. And while this is starting, I'm going to go over here to this window and show you something. Let me go find the right window. Let's go over here. So let's go to 2AV. This is all here in our GitHub repo. Okay, so I'm going to run a command called crashsql.cmd, and that's going to run SQL command with this SQL script. What does that look like? This is an internal dbcc command, which is not available to you. And you're like, Bob, why isn't it available to you? Because why would you want to go do a disaster? Here's what we did. We have something called a unit test inside SQL Server, and we're using the Swiss Army knife of SQL dbcc to do it. And there's a series of these things. So we've built in testing so we can generate access violations anytime we want to see how the server will behave under stress. So I'm going to go run that and see what happens. So let's go kick it off. So I'm going to go over here. I'm going to run crash SQL.cmd. And I'm going to go over here. Oh, see that little window that popped up? So I mentioned earlier something called SQL dumper. So what happens is whenever we have one of these access violations, we do this in the error log. Maybe you have seen something like this. Hey, I've seen that, Bob. I didn't know this was going on in my system, and I looked up, and lo and behold, in my error log, I got something like that. Do you see that? You see here that I got something called an access violation. There's that code. Now notice here, it says writing address 000. So what this unit test does is in the code just generates randomly the ability to write to a null pointer. And what's really cool about this often is you get something called, and I'll go and look at that again, you get something called an input buffer. Maybe you've seen that. This is super handy. And in the early days, we didn't have this. So one of the cool things that Keith and Bob and I did all the time was give feedback to the engineering team, and we happen to have this really cool guy named Slava Oaks working in the team that loved us. So early on, we didn't have that. So we're like, hey, can you guys just add in the query if it's available? Well, we can do that. So we put it like in a CU update or something. So all of a sudden now, we would get this, you would call us, and we would say, hey, what is that right there? You're like, I don't know, it's some select statement. Can you run it again? And you do, and you'd hit that. We're like, give us that. Give us the repro, we'll go fix the bug. So that input buffer is very handy to us. Doesn't always happen because sometimes access violations happen in background tasks. So when that's blank or empty, it means it's not based on a single query. So that's pretty handy. In this case, you can tell I'm just doing this unit test thing. Well, what does this look like inside the code itself? Well, this is where the debugger comes into play, and this is often what we would go do. So I have already predefined using the debugger, but I want to show you how I'm doing that. Debug av.cmd. How do I do that? This is using the Windows Debugger, and that -y command is called the symbol path. So symbols are like names based on addresses, like function names. Now, you would normally use a symbol path like that first part, which is like the public symbol server where SQL Server publishes its symbols. I have to attach in some separate paths for the debug version of SQL because it's private symbols. But I'm also going to use the public symbol for Windows as part of their call stacks. The -Z says, hey, don't debug a live program, just load up a crash dump, a mini dump, and we produce these files in a format that's documented so we can go look at those. So let's go do that. Debug av.cmd. And you're like, great, Bob, what does that look like? Now, first of all, we are the one producing the dump at Microsoft. So we can do certain things like put information in the header of the dump. You can write information in there. It's a known format. Notice at the beginning it says fault handler exception access violation. So SQL Server adds into its dumps information about why we generated a dump. So if you send an email to me today, you can. Hey, Bob, I'm getting one of those things. You know what I might say? Hey, look, if I got some time, can you just share the mini dump with me, this MDMP file, which is what I was attaching? The first thing I'm going to do is go look at that header. Oh, you're getting an AV. I don't have to look at your error log. I can see. Now, in order to get the right context of this access violation, I have to run this command, and it tells me to do that here. It says, hey, you need to run this command in the debugger, .ecxr. I do that. Now I can dump out a call stack. But before I do that, let me show you that I know already where this access violation is occurring by the following. Let's do this. Oops. So right here, I know this is the code. Now look here, this is interesting. I know here what I'm doing is I'm moving this constant right here. Let me redraw that. I'm moving this constant here into RAX, but not RAX, the pointer to RAX, which is a 0. So the brackets mean a reference to. So it turns out that in our code, what we're doing is we're just simulating an access violation by writing a constant value into a null pointer, just like I showed you in my code. But we handle it in the code ourselves. So this is an example, and I can look at the full call stack, which I might do. Like if I saw this immediately and you called me, I said, oh, let me do a K command to look at the entire sequence of what's going on. And you can see this sequence of commands here. This is starting out from a thread all the way here. This right here is the actual function calls to go run SQL commands like queries. And then if I go up the text, you can see here, this results into some of our code. Specifically, here's that unit test code. Our disaster test case, we have several of them that we can simulate. And here's one called an access violation test. So if you sent this to me, I would look at the sequence in the code, and I might be able to tell already where it is. Oh, it's in a hash join, or it's running some sort operation, or I don't know, it's in a CLR routine, or whatever. So a lot of times, we can just look at the mini dump ourselves and tell exactly what's going on in source code. Many times we can't. Sometimes we cannot reproduce these problems, which is why that input buffer becomes handy for us, right? Here's a quick tip for you. You're running SQL Server on premises, and you get these problems. You end up calling support, typically, right, to go find out the issue of what's going on. What is the first thing they're going to ask you to do, you think? Are you running the latest cumulative update? Because there could be a KB article out there that points to access violations that are already fixed based on the version you're running. What about the cloud? People have asked me before, like, well, what do you guys do in the cloud? You know what we do? We monitor these things. We constantly look for these things. We have programs that actually go take a look at this stuff, search for known bugs, and if necessary, patch your server where you don't even know what's going on. Or proactively file a bug where a developer has to go, he's forced to go look at this, fix it, and eventually roll out a fix to your cloud databases. So one of the advantages of the cloud, I'm not just a marketing pitch for the cloud, I'm just saying we have automation in the engineering team to go proactively fix access violations. But if you report these to us, sometimes we go and create a fix for you, or we try to roll that into the next cumulative update. Okay, so that's the world of access violations. Kind of an interesting world. I would not say to you today that I'm trying to present to you common problems. It's not like when I was in 20 years in CSS, I got a call every day on an access violation. Actually, I did. Why is that? Because I'm like the fourth line of support. Like everybody doesn't get calls to the product team with these happening constantly. But the time Bob and Keith and I got it, we saw these. And what you just saw is an evolution over time of what we've produced in the product to catch these things and to go debug these things. So that's kind of pretty cool to see what an access violation looks like. Quick tip for you. If you ever try this in your laptop or your test environment with a debugger. Now this is just a dump file, okay? If I actually tried to go debug the server, let's go look at that. Let's try to do this. Let's kind of do this. Let's go debug SQL.cmd. Now let me show you what this looks like. Now in this case, I'm doing this command. I want you to attach to SQL Server that's currently running. If you ever tried this before yourself at home, you need to be careful. Because if you try to go run this and attach, you'll bring up the debugger, which is lovely. I always sometimes have a hard time docking this thing. What have I done at this point? I have halted SQL Server. So when you attach to a running process, you're freezing the process so you can't connect and run queries. And then if I did something really nasty like this, I'm like, oh, let me just go ahead and just quit. That sounds great, no problem. Go over to my window over here where the debug server is running. Uh-oh, I shut it down. So if you attach a debugger to a running process and you quit, you will kill the process. If you do .detach, no problem. We just detach the debugger and you can kind of keep running. All right, that's an access violation. Let me stop and see whether all of you guys who know how to debug access violations have any questions. Anybody in the audience? Something you do every day, right? Boombox, please.
Do you also offer the debugging tools then on Linux and on Kubernetes for debugging sessions?
Yeah, you're like, how do I debug Linux? Is that what your question is?
Yes.
Yeah, what the heck, man? So if you go back, I don't even know if it's in the past records or not. I did a session on Linux at PASS a couple of years ago, and I showed how to debug Linux. Since we run in this PAL environment with SQL on Windows with Linux, we actually have we have to attach the Windows debugger to another debugger we wrote to make it work, but we can do it. We can do the same thing. We can debug the native part of Linux with Linux debuggers, and we can debug the Windows part running on Linux with this debugger. So we can do it. You can't do it. You would not be able to set that up yourself in your environment. But you know what? The dump files are compatible. So if you got a dump file on SQL on Linux, one of these dump files, you could just bring up the Windows debugger and look at it. No problem. Anybody online? All right, let's go ahead and march on. Does anybody know what this building is? If you know this building, I'm very impressed with you.
I do, because I heard the story.
Andy's heard the story. Andy, it's not fair. You can't sit here and do it. But go ahead, tell us, Andy, what's that building?
Where you and Bob used to take your walks.
This is the offices in Las Colinas, Texas, for the Microsoft offices in Irving, Texas. It hosts about a couple thousand people. And it was actually built in the late 90s. And so this is like my third different building I'd been to at that point. So what happened is that I decided to, because my wife told me I was getting older, she said, during lunch, I'm going to give you a brown bag lunch, and I want you to start walking during lunch, because you're just sitting down all day. Like, okay, hon, I'll start walking. So I start walking around these buildings to get some exercise. Rain, sleet, snow, 105 degrees in Texas. Keith and Bob said, what are you doing? Well, where are you going? I said, well, I'm doing a walk. They're like, well, can we go with you? And I'm like, sure. So the first couple of weeks, we're just walking around talking about family and home improvement and stuff. Finally, Robert Dorr says, hey, isn't this thing bugging you about hangs in SQL Server? I'm like, what do you mean? He goes, well, every time the product hangs, this is way a long time ago, guys, all it happens is nobody knows what's going on, and we have to attach a debugger and get a dump, and it takes me hours. Does that piss you off? I'm like, yeah. And so we started designing a system in SQL to fix this. 2 hours later, we're walking around. Our manager came out and said, where are you guys? We're just out there walking around. You know what it led to? It led to a decade of us walking during lunch and solving some of the most common, some of the things you see in the product, like extended events and all this stuff, was us walking around these buildings, dreaming up these ideas, sometimes forgetting what time it was. And one time, one of the managers came up and said, like, the three of us were walking a little close to the road. He said, okay, you can't do this. If somebody hits you guys, there's going to be a big problem in CSF if somebody hits you, right? So we were designing this new hang system. We talked to Slava Oaks about it, and we said, hey, what we're noticing is SQL Server being a non-preemptive scheduling system. That's what it looks like. That's what's happening. Some of the code in SQL Server is not yielding. And we would see this every time in these dump files. We would attach a debugger, look at this code, we're like, what the heck's going on? With Slava, can you do something about it? He's like, yeah, how about I put something in the error log like that? So at least you guys know this is happening. Perfect. So then customer would call us. We're getting a hang. Hey, you getting one of these things? We're like, okay, we got a non-yielding problem. We got to go solve this. And eventually what would happen is, if it happened long enough, you would get what? A stack dump and a mini dump. So you could send it to us. Now we could look at the mini dump, and we would know it's a non-yielding problem. Because before, you know what we were doing? We were calling you and saying, attach a debugger in production. You were like, what the heck are you talking about? I'm not going to put this WinDBG thing on my server. We're like, we don't have a choice. That's the only way to solve this problem. So this was just groundbreaking for us. Back in the 2000 days, we started doing this. We started hitting these issues. So I presented this slide one time, and somebody said, I don't understand what you're talking about. Like, what is this non-preemptive business? I went back and found a slide. Oh my gosh, I'm dating myself. From past Summit 2012, where I did a talk on SQL OS. See how old this slide is right here, right? And I explained how scheduling works in SQL Server. So look at this slide right here. In any given scheduler CPU, a thread is what's called on the scheduler, and SQL OS ensures only one thread at a time is running. Now the other thread, thread X, is just another thread in another program. So on a CPU, Windows is preemptive, right? It can switch back and forth and preempt both those threads. But our thread in SQL OS is the only one running. Now, how do we guarantee that? Well, look over here. These are other threads that are worker threads that are waiting. Like these are the ones waiting to run, and these are ones that are waiting like on a timer, like waiting for 60 seconds to run, like wait for a call or something. Now you may be asking yourself, how does Windows not go preempt those threads? It does, but it doesn't. It turns out if you wait in something called infinite in your code, the operating system skips your preemption. So that's what we did. When we wait in a worker thread in SQL Server, we wait infinitely forever. So Windows says, oh, I'm just going to run those two guys. I'm just going to skip these, so it doesn't ever try to go preempt our non-preemptive threads. Now, here's the problem. We sometimes have bugs in codes. I realize that's kind of rare, but we do. And that SQL OS thread 1, if it runs for a certain amount of time and doesn't switch back to these folks, you get those previous error messages, called a non-yielding problem. Let's go look at it. Okay. So I'm going to use that debug server again. I'm going to crank it up again. And I'm going to go run the disaster. I'm going to use the unit test again to cause one of these problems. You know, by the way, just real quick story for you. Before we invented that unit test, which was our suggestion, Bob Doerr's suggestion, when I tried to go do this back in the day, I had to go find known bugs we haven't fixed to show these problems. Turns out most of the time we'd fixed them. So like, how am I going to go show a non-yielding or an access violation problem without creating my own instrumentation of the code? So this unit test is very valuable to me to show this off. So let's go over here. Let's look at hang. So let's look what non-yield looks like. Same thing, same disaster command with a different option called non-yield. So let's go run that and see what happens. Go back over our debug thing. Notice it says starting non-yielding task. Now, here's the rub. What we do is we don't want to go trigger this falsely all the time. So what we do is we wait like 60 seconds to say, if you've been not yielding for 60 seconds, we're going to start dumping some information. So while that's running, I've already pre-created one of these problems, and I want to show you in a debugger what the dump looks like. Let's go over here, back to here. So many windows, I don't know what I'm doing. Okay, so let's go debug hang. Now let me show you what debug hang looks like, by the way, and make a comment to you. So you've got a SQL server, and you're like, you know what? My SQL server seems to be fine, but I don't know if I'm getting these dump files. Go to the log directory. You see that up there on the screen? Go to the log directory on your SQL server and see if you have any files with the extension MDMP. I actually presented this a pass. Somebody came up later and goes, hey, this is pretty interesting. I'm going to go back and do that. Can I email you? Sure. 2 weeks later, it says, I had 40 of those. I'm like, you did? So he went, there's actually a dumper log file that is a history of all these. And it turns out he was getting these often, but SQL was just keeping these AVs going. And sometimes they were non-yielding problems, and he didn't know it. But he said, you know what it is? He goes, it's funny. I know some blips in performance. Like every once in a while, the server seemed to hang. I'm like, hey, I think you've got a problem. Turns out he put on the latest cumulative update and it went away. But anyways, I'm just saying, maybe you'll go back to your SQL server and see if you've got some of these dump files. So that's what I'm going to run. I'm going to load up a dump file and see what it looks like. See how is it different than this access violation we talked about. So in this case, we don't need this .ecr command. We'll just run a K for a call stack, and we'll see what it looks like. And if you scroll up here, you can see indeed, right here, you can see right here, we're calling this. Now you may be asking yourself, how do you know that's a non-yielding problem? Like, how did you know just by looking at that? Here's why. Let's go down in this dump file and look at, remember the worker threads on the right that were behaving nicely? Let's go run this command, bang unique stack. Okay, here's what that's for. So SQL Server has worker threads, and a lot of them aren't doing anything. So the call stack is identical. So if you did a K of all the threads, you'd have like 40 of them that look the same. So this command is beautiful because it says only produce the unique call stacks. So this is all the call stacks in the system, and it running. So I'll run the whole thing, wait till it finishes at the bottom. Now let me go up from the bottom and scroll up and show you something. I'm sorry? No sound? Can you still hear me? Because I'm really loud, but the people online can't? Are we good back there? I'm sorry? Okay, I think we're okay. I'm sorry? Okay, maybe the speaker's out or something like that, I don't know. So maybe it's an access violation, it crashed. Sorry, I couldn't resist. So notice here, this thread that we're talking about is this non-yielding problem, right? Look at the top of this. It's not waiting on anything. But if we go and scroll up a little bit, let's look at this one. This is like a background thread for always on availability groups. Notice here what's happening. This has got the SQL code in it, but look at this code up here in the SQL DK. What the heck is SQL DK? That is the DLL for SQL OS. So that's an example of a worker thread properly waiting on something to do. Now here's how yielding works in SQL Server. How do we do this in the code? Well, first of all, developers got to be pretty smart. They have to know, are they running something that's very CPU intensive and decide to yield every once in a while? So literally, when you see SOS scheduler yield, anybody ever seen that before? That's an indication that our developer said, oh, I need to go yield back to somebody else because I'm running something intensive, like a sort or a hash. But we're pretty smart about stuff. When you go block on a lock, you don't need to yield. You do a wait like this. When you go wait on a latch, when you wait on network and I/O, you're naturally waiting. Here's another clever thing we did. Somebody wrote in the code, so if you're getting pages from the buffer pool and it's all in memory, we have something called smart yield. We say, oh, if you've read 100 pages in a row, yield. So a developer doesn't have to worry about that. So we have intelligence in the way the developers write code to make sure we're yielding properly. Any waiting operation, though, is naturally a yield in the system. So somebody asked me when I was building, they said, okay, now I'm confused here. The guy that was not yielding is this piece of code. Who dumped out that call stack thing? How did you know that? This is what Slava and the team put in that was beautiful. They wrote a background task called the scheduler monitor. The scheduler monitor happens to run on its own scheduler. And in fact, it doesn't even do that. It runs in preemptive mode. So the scheduler monitor does not participate in a SQL OS scheduler because all it's doing is trying to catch people that are running on schedulers incorrectly. So if you look at here, notice this call stack. You look up, you can see here, here's the scheduler monitor, and it's doing something called, look, I'm way off my thing here, check schedulers, and now it's actually executing something called non-yielder scheduler callback. So what it's done is it has gone out and looked at the system. It knows how to go look at all the schedulers and say, I found one that's not yielding for 60 seconds. Because we have memory structures, which you see in DMVs, like DMOS schedulers. It knows how to go iterate that and say, I can tell somebody's not yielding properly, which is pretty cool. So I'm like, okay, well, how does it actually work to actually produce the call dump? Let's go up here and see this. This is the magic. It says, okay, I am going to go capture the stack trace of all the threads in the system and invoke SQL dumper. So here's another little fun thing for you. There's a program on your machine called SQLdumper.exe that you didn't know existed. And so what we do is we do a create process call when we have this happen to spawn a process called SQL dumper that generates the mini dump for us of the SQL Server process. And if you call support today and things appear to be hung and you don't know what to do, instead of attaching the debugger, you know what they can tell you to do? Run SQL dumper manually to go generate a dump of the system so we can go analyze the process. Or if you can connect to SQL Server, you can run that dbc stack dump command. Don't do that in production. That can also generate a SQL dumper as a process. So creating the SQL dumper process was light years for us. Because all of a sudden now we didn't have to tell you to go attach a debugger or something when something was crazy. Let's say we couldn't figure out this non-yielding problem. We would just say, can you go run this dumper program for us and get us this mini dump file? And what would we do with it? -z mini dump. We would go look at all the call stacks in the system to see what's going on. So great example of a non-yielding problem and how SQL Server tries to respond to it. Okay, so again, if you're attached to a mini dump file, it doesn't matter if you do Q because you're offline looking at a file. So you can just quit, it doesn't really matter. So a pretty cool example of a non-yielding problem. I want to back up for a second. I just kind of skipped over this, but I'm going to show you one thing that there's a demo in the demos you can run yourself about another case of not yielding, but it actually is yielding. What are you talking about? Consider this common scenario. A request comes in, like a query, and opens a transaction and just sits there. In other words, run a query, open a tran, go to sleep. Common developer problem. Developers never make mistakes. You all know that. So we have something called a worker pred rule. So you run this transaction, and everybody else comes in and is blocked on that. And the worker thread pool becomes full with all the workers waiting. What happens? Well, what happens is somebody tries to run another query, cannot get a worker thread, and gets a thread pool wait. This is bad. And in fact, if this becomes a problem across all schedulers, you get that. So that is not a non-yielding problem. You see, everybody's yielding properly. It's just the fact that everybody's blocked in the system. In other words, our schedulers are deadlocked with each other because somebody's trying to run a query. And for a long period of time, we didn't have that diagnostic either. So what did we do? You ever heard of something called dedicated admin connection? That's another CSS walk special. We were walking around the building, and we were talking about this problem. And Keith turned to me and goes like, you know, what if we created like a back door in the SQL Server that didn't use the scheduler that kind of do some brief stuff? Because then what we could go is we could go in and kill that session and free this up without actually, you know, trying to restart the server. So that's what we did. We invented a dedicated admin connection to go very much do that exact thing. Here's what's really neat in latest versions of SQL Server. This is how clever the server is with the deadlock manager. Turns out if you come in and this request comes back and tries to run a commit tran, what would happen, you think? Would it get the thread pull wait? No. We're clever enough to let it run. We can actually go let it run behind the scenes on a worker and free the whole thing up itself. So after a while, the developer said, like, well, why do I have to run dedicated admin connection? Can't the server just figure this out? So it's a great example of intelligence of how we've done that. Okay. So another story real quick. Let's see where we are on time. Oh, we're doing good. We only got 13 minutes left, no problem. So here we go. 2005 comes along. We're talking about these non-yielding problems. And one of the issues we ran into is this. We would try to go get those call dumps. There would a piece of code of SQL Server that would run a Windows API call and wait, like trying to authenticate your login to a domain. It happened over and over in these dump files. And the status would be running on the request. We're like, what's going on? You know, we told Slav and the team, can't you tell you're waiting on an API call? They're like, yeah, we can do that. So they introduced the idea of a wait type called preemptive _ something, which is like your OS calls. And if you look here, here's some examples of them. So in 2008, we introduced the ability to tell you you're running, because we can't tell if you're waiting, but you're running some API call that's causing a problem. So sometimes you can go try to solve these problems, sometimes you can't. One of them is auto grow. Here's a slide. You talk about a throwback slide. Look at these kind of symbols, right? Yeah, look at this, how old this thing is, right? You try to go run an insert, you need space. We go acquire a latch on a control structure to get you space. We need to grow the file. When we grow the file and zero it out, we call write file gather. So what happens is this person's pissed off because they're waiting on this write file gather, and you would see that wait type in the system. Now what happens to everybody else? They need space, but they're going to wait on that latch. And that's a common problem for auto grow. Quick, fun tip for you. Come to Hidden Gems on Saturday. Come to Hidden Gems on Saturday, and I can solve this problem for transaction logs now. So for database files, we have solved this issue because we have instant file initialization, which solves these long growing problems. But an example of us doing an OS call to the operating system and waiting. So here's what we do. We made a decision during this to take those threads off schedulers. So now what happens is, starting in 2008, is you would see these wait types, but you would not hang your system. So they don't call non-yielding problems anymore. And if they do, we made a mistake in our code. So anytime we make these API calls, what we do is we go into what we call preemptive mode. where the thread is not part of that scheduling system. It just runs on its own, and Windows is allowed to actually preempt it because it's not waiting infinitely. You know why? It's not waiting in our code. It's waiting in some of their code in the operating system. We don't even know where it's running. So it's a really nice innovation that we added, again, based on the walk around Las Colinas, to go actually help these kind of problems. Xevent can be your friend without having to do a lot of debugging. There's a lot of information you can gather about waits, about preemptive waits, about latches that take forever for I/O timeouts. You can send data to files. And if you didn't know this today, and I'm shocked that people still don't know this because it's probably my fault, there is a default Xevent session on every SQL server in the world that captures a lot of stuff by default. So you can go into the system health session, which is tracked in a series of files, and look at a bunch of health information about SQL Server, including all this kind of stuff, on your own, anytime you want to look at the health of SQL. And where did that come from? The walk around Las Colinas. We literally said one day, Bob Dorr did this. He's like, can't we just create an Xevent session that just captures a bunch of stuff by default and call it a health session? We went to Slav, and he's like, we can do that. And so I believe it was back in SQL 2012 that we added that functionality. Okay, so let's finish off and talk a little bit about Spinlock. So we have about 9 minutes left. So people have asked me about a Spinlock. Somebody called it a lightweight lock, a lightweight latch, all sorts of things have been called. It turns out in SQL Server, when we wait on things in SQL Server, because we have something called thread concurrency we need to do. There's 3 levels of it. One is a lock. That's what you see consistently wise. Another is a latch, like a physical protection of a page or a structure. It turns out in all those cases, we must use kernel APIs to wait on things or concur with each other. So in order to be really, really fast, that's what people like Connor dream about. Connor's got an amazing session at 3 o'clock to talk about just stuff he does that's mind-blowing. Maybe you won't have any questions there either, but you might. So what we decided to do years ago is say, hey, there are situations where we need 2 threads not to touch the same memory structure to be concurrent with each other in order to be thread safe, but a latch is too heavy. A lock is, something's too heavy like that. Let's create a concept called a Spinlock. It's a computer science concept, and this is what it actually looks like. So we go into a piece of code and try to acquire what's called a Spinlock. It's an integer value in a memory structure. And in order to do that, we call an actual API call, interlock compare exchange. Now what's really cool about that API call in Windows is they turn that inline to assembly to make it very efficient and fast. So when we try to go get one of these Spinlocks, we expect it to be acquired quickly. But as it turns out, what can happen is somebody else may have the Spinlock for a certain reason. And if somebody else has it, we call that a collision. So what we do is we spin, which is effectively a loop in the code, like a little tight while loop. So you can imagine if this happens very quickly in the system, you're not going to see any problems. But what happens if this happens a lot? This yield call, this loop, is a lot of CPU utilization. So what we do is if we've spun and we still haven't got it, we have something called a limit. And if we hit that limit, we try to go get it again. And if we can't get it, we do what's called a backoff. A backoff is literally now a Windows call, or in Linux call, to sleep or wait. And if we do that for a long period of time, we can become sick, which is what we call a sick Spinlock. You yourself can see this with an Xevent, something called Spinlock backoff. You can also see this, by the way, in something called Spinlock stats. There's another DMV to look at Spinlocks. There's a backoff call. So if you want to go see in your system, do I have unhealthy Spinlocks? You would go look at how many backoffs are occurring because you can see the sequence. If we've gotten all the way there, that ain't good. Now here's what happens. If it's sick and we've backed off for a long period of time, we have something called a backoff warning. Those are really bad. So personally, I would go set that Xevent on my system and just see what's going on. Do I get a lot of those warnings? Because if you do, there is something serious in the system. And by the way, guess what? There's no Spinlock hint in SQL Server. You don't control Spinlocks in SQL. We do. So if you run into these kind of type things, you need to talk to us. If we hit this sick situation, we increase the limit. So we spin longer the next time to make sure we don't have to go back in this sleep scenario. So in the instructions, in the demos, is a way for you to go try this yourself and see this in action, to see the Spinlock. But I want to show you visually what it looks like. So we had this problem, which we fixed. In order to do the demo yourself, there's a trace flag to go undo the fix. You know, one way to kind of undo what we're seeing just to see it. So notice this situation. A bunch of users have an open connection for the same database. It turns out in our locking structures, what we did before the fix is, everybody was lined up in what's called a hash bucket on the same hash bucket, 1,000 people. So if you were running like a connection pool with a reset, like an SP reset, we would have to go find you in the list. Well, this is bad, because here's what happens. We have to go acquire the Spinlock for that hash bucket to find you, and we have to search that entire list. So what we were seeing was massive Spinlock backups on something called a lock hash. And our call dumps, our stack dumps, told us this is what was going on. So very quickly we looked at this and say, you know what do we do in a case when we have a problem like this? We partition things. So our solution was that we partitioned all the users into their own partition. So everybody now looked like this. So to go look up you, it was pretty easy to do for your partition. And we partitioned it by CPU. Look at the performance differences here. So we had a scenario we built with SP reset connection to a connection pool where it was crazy before, and after the fix, it got really, really good. It's a great example of us using our debugging tools to try to go solve a common problem, but your symptom of this, I showed you, is Spinlock backoffs, warnings, and even looking at Spinlock stats. Another common problem, another unusual problem that we had to go use advanced debugging techniques. So let's finish here with the final story, and that is this. I, as a child, love Encyclopedia Brown. Anybody know that, the book? You're like, I'm not a kid in the US, I've never heard of that book. Go look it up. It's a young man that was like a Sherlock Holmes. Like he always subbed these young detective stories, but it was written for like school children, right? But I ate this up, I just love these things. Bob Dorr came to me one time and he said, hey Ward, he always calls me Ward, see if you can figure this one out. I'm like, what? He goes, take Management Studio on my machine, I have RDP in this machine, and try to go expand databases on here, or tables. I'm like, all right. I did it, and it just did this. It just sat there with a spinning wheel. I'm like, what's going on? And he's trying to repro it on your machine. I did. It didn't happen. I'm like, what? How'd you solve it? How did you know? He goes, I know the fix for it. We use something called xperf. I'll play this. xperf allows us to trace call stacks for a live process to see where are we spending the most time. Because you know what's going on? It was the same query behind the scenes of Management Studio was running in both scenarios. It's like the same query. Why is it happening in one and not the other? Well, as it turns out, in our code, we were having to check to see if we had permissions to go do this operation. So deep into our code, for every row in a hash join, we were checking permissions, all CPU bound. How are we going to go detect something like that? Profiler or looking at query store, whatever, shows the same query. One's taking longer, one's chewing up CPU, one's not, but the plan's the identical plan. So consider this, same query plan, same operators, one takes a bunch of CPU, one doesn't. How do you figure it out? We use xperf as a tool, which is available to you, by the way, to go look and say, where is the code most being run? We do this sometimes to solve some of those complex CPU-based performance problems that we have in SQL Server. Just another example of the tool set we use for advanced debugging. But I have actually had customers and told them in some cases in a test server, they too could actually turn this on, go look at this with symbols, give us back this information, and we can maybe go detect a problem in their system. But think about the symptoms here. It wasn't a Spinlock problem. It was a CPU problem. Same query plan, but unexplainable CPU. And xperf is an example of something that we use to go solve that. So look at this. 2 minutes to go, and I think maybe you have survived the brain explosion zone. So let's see if, the last 2 minutes, if you have any questions. Yeah, go ahead, online.
What is the reason for making SQL Server thread handling non-preemptive?
What is the reason to make SQL Server thread handling non-preemptive? It's all about performance. If we let Windows preempt us all the time, we could never perform to the level we are. So what we decided to do is, look, we know best how to perform database processes. And so we decided to go make our own scheduling system to make it super fast. And that's exactly the reason why. But we make mistakes sometimes. Boombox right here.
Hi. What about self-deadlocks in use cases involving parallelism?
The question is that what about self-deadlocks or parallelism? And that is a tough problem we run into, there's no question. That is sometimes a bug in our own code. And by the way, sometimes we solve that. You know how? We get a mini dump to go figure out why are our threads having deadlock problems with themselves. Yeah, go ahead.
Short funny story, we opened a support case for such use case in Azure SQL.
Okay.
And the first response from the support was not that it's a bug, but something about don't do this query or improve performance. So that's a bit.
Can you come up and tell me up later the story? Because I'd like to hear that, because I don't agree with that. So.
Yeah,
yeah.
me neither. I just wanted the confirmation for you,
tell me the
basically.
story. I don't agree with that necessarily. So, hey, you've been a great audience. I thought you found this kind of fun and useful, something you don't normally see at a conference like this. So you just relived what my life was for the first 20 years at Microsoft and the evolution of how we built diagnostics in the system. So hope you have a great rest of the conference at SQL Bits.